I'd like now to look at the electronic structure and the periodic table. I've said to you in I forget which unit it was that elements are arranged in a table, the periodic table. They're arranged in groups going up and down and across in periods. In the previous video clip I said atoms consist of a central nucleus surrounded by electrons. These electrons are not at the same energy levels. They're buzzing around the nucleus, but they are contained in different shells. So a very simple picture would be this. There's the nucleus and there's electron shells. Let's just make it simple, 3 electron shells. The center contains neutrons and protons, and these are the energy shells. Let's call them shells 1, 2 and 3. The first shell can only contain 2 electrons. The next energy shell can only contain 8 electrons. And the third shell can only contain 8. Let's look at the electronic structures of some elements, right? Previously I've mentioned sodium, atomic number 11, number of electrons 11, its structure in terms of those shells would be 2 in the first shell, 8 in the second shell and 1 in the third shell. So sodium, its structure is 281. Oxygen now, O8, its structure is 2,6. And another example, chlorine, 17. Its structure is 2,8,7. And a final example is silicon, which is 14. Its structure is 2,8,4. It's the number of electrons found in the outer shell that determines its chemical properties. Elements found in group 1 have 1 electron in its group in its outer shell. Elements found in group 4 have 4 electrons found in its outer shell. So that's the electronic configuration. I want now to look at the periodic table. A Russian guy, Dmitry Mendeleev, a long time ago, he arranged elements according to their atomic weights compared to hydrogen. Hydrogen, by experimentation, he said, let's give it a value of 1. So all of the other elements were based on their weights, their atomic weights, compared to that of hydrogen. Don't forget, they hadn't even discovered neutrons, protons and electrons going back to Mendeleev's day, and he devised a table based on the weights. However, he found that it didn't fit all of what he thought. You know, what I've said, elements of different groups, different periods, and he tried to draw up a table in which elements were arranged in their atomic weight, but he found that elements didn't follow that. And what he then concluded was there must have been other elements which are not even found, which would give you a better picture of the periodic table. I said in a previous talk that a very simple picture of the periodic table was like this. That was hydrogen, H. helium, and it consisted of rows and columns. The things going across are called periods, the things going down are called groups, and that was group 1, 2, 3, 4, 5. Hello, I can't count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is a very simple picture of the periodic table. Mendeleev, however, he found there were gaps, and once I get down to the third period, that is that's 1, 2 and 3, there were other elements that had not been discovered, isotopes had not been discovered, and there's a block between this part of the periodic table, that part, and this is the transition elements. Looking at, like I've said just a minute ago, lithium's found in group 1, sodium's found in group 1, going down those groups because they all contain the same number of electrons in the outer shell. Gradually going across the periodic table, it changes from metals to non-metals. Let's look at the properties of metals a bit now. The physical properties, metals, and the opposite of a metal. This is metals, and this is non-metals. Metals have high melting points, high boiling points. When you hit them, copper, say for example, they are sonorous, they make a noise. You can bend them, malleable is the word for that, malleable. You can pull them into wires, ductile, and two more important properties of the metals is they conduct two things. If something generally conducts heat, it also conducts electricity. Metals, by the way, Mercury's a naughty boy, but they're generally solids. So that is the difference I've outlined between metals and non-metals. Is the opposite of that. Low boiling point, low melting point. They don't make any sound when you give them smack them about a bit. They're not malleable, they're brittle. Ductile, you can't stretch them, and the poor conductors of both heat and electricity, and often, well, not that often, they can be gases or liquids. For example, chlorine's a gas, therefore it's probably a non-metal. Nickel is a solid, it's therefore a metal. I just want now to look at simple things that happen to the metals. Here's a simple equation. Metal plus oxygen combine together to form an oxide. Let's take another example. A metal plus chlorine. Would you believe it? gives you a chloride. So metals react with non-metals to form compounds. For example, sodium would react with oxygen to form sodium oxide. Sodium would react with chlorine to form sodium chloride. But how do they do it? Well, this is how they do it. Let's go back to the electronic configurations. Let's take, for example, sodium. There he is. There's the nucleus again. And there's these electron shells. We know this, that the first shell contains 2 electrons, the next shell contains 8, and the outer shell that's not firmly held, because that is further from the nucleus, they are closer, and those 2 electrons are closest to the nucleus. Therefore, when sodium forms compounds, it loses that electron there. Let's look at it in a different way. Sodium again, he keeps on cropping up all the time. He's a naughty boy. He's 281. That's the atom. When it reacts with oxygen or anything else, it loses that electron and it forms 2,8. If it's lost some negative charge, which electrons have, it then becomes something positive. So this is the electronic structure of sodium, and its ion is Na+. If I took something like calcium, it's found in group 2 because it contains 2 electrons in the outer shell. So if it loses 2 electrons, it would form an ion of Ca2+. Aluminium next. Aluminium found in group 3. Why? Because it's got 3 electrons in the outer shell. It loses 3 electrons and would form Al3+. These ions, there's 2 types, would you believe it? Positive ions and negative ions. These positive ions are called cations, and negative ions, let's look at them. So metals form cations and non-metals form anions. Let's look at chlorine. Chlorine, his structure is 2,8,7. And if it gained an electron, plus 1 electron, it would then be 2,8,8. So this is gained an electron, a negative charge, so chlorine would go to Cl-. Oxygen next. If it gains 2 electrons, it goes to O2-. So that is a fundamental difference between metals and non-metals. And would you believe this? Metals combine with non-metals, in which the metal loses an electron and the non-metal oxygen, we've just seen chlorine, gain them. I'll be speaking more about this in the next module, in which I look specifically at certain groups. Group 1, the alkali metals. Group 7, the halogens, fluorine, chlorine, bromine. And Group O, the inert gases, argon, neon, krypton, etc.